Hello then, welcome to this Pandas challenge, day 24 of 30. My name is Valentine and I'll be your instructor. In this challenge, we are going to be continuing our Pandas library journey of getting to learn and practice different Pandas concepts important for data analysis. So let's get started. The first thing that you need to do is to visit the description section of this video, and you should get the practice resource link that should take you to a page that looks like what you're seeing on your screen. Once you get here, click on the sample practice resource, which should eventually take you to this particular resource. That's the sample notebook that you need to make a copy of. So once you get here, go to File, then save a copy in Drive to make a copy of this notebook, and it should open a new copy in a new tab. Use that and close the original file, notebook that you have. This will just allow you to be able to make or to access the changes that you will have made to the practice work that we're going to be covering today. If you're an Afterwork member, there's a practice notebook that you'll get, and that's what we are going to be using. I'm going to be using that. It's similar to the sample practice notebook. The only difference is that there are more challenges in the practice notebook than there are in the sample notebook. In addition, as an Afterwork member, you get access to the solution notebook. Right, so let's get started. The first thing that we need to do is to, once you have saved a copy in Drive and you have a new copy, you need to connect this notebook. You can click on the connect icon on the far right. That should eventually get to this particular point where you just have a check. And by the way, feel free to pause the video as well as rewind the video just in case you feel like I'm too fast. Okay, so let's get started first by importing Pandas, the Pandas library for data manipulation, which we have, and then we can get started with the first concept. So in situations where we are looking towards answering research questions using datasets that have date time information, then we would need to convert the columns that contain date and times into an appropriate format, into a format that contains date time type of data. So assuming that we had this data set that we might want to use for research, answering a research question, this data set contains information about patients, and we had these two columns, or three columns, which contain information about dates. If we wanted to work with this date and use it maybe for creation of visualization, such as time series plots, or if we wanted to calculate maybe differences in the dates, just to know maybe how many days maybe a patient was admitted, we could use maybe admission minus discharge date minus admission. That should give us a number of days. But in order to perform such date operations, then we need to convert that date into a date time format. So so we're going to learn how to just convert the following dates into just a date time format. It's a concept that we've done in the past, or we've covered in the past. So initially, we first of all load the data and then check the data types. So we can see in this case, admission, discharge date, and also follow-up date. They have object data types, which means that, those columns contain textual data. But from what we can see that it's date information that they actually contain. So in order to convert now those three columns into a date time data, to have a date time data type, we can use the toDateTime function, and we pass the column name that we would want to convert to have a date time format, and we can specify the format. Most of the times we need to specify the format, especially where you have maybe some date information that may not necessarily be that obvious. So if you're converting date to have a date time format, you might as well do this. In some cases, some data sets do not require you to do this to define the format type, but here we're just defining mixed. So this should, the values that we get here after conversion should replace the original values for admission date, discharge date, as well as follow-up date. And lastly, we preview the data types. So you can see here we have date time 64, which is the date, which is the type of data type that would be appropriate for performing time series analysis or answering research questions that require time series data sets or or data with date components. Right, pause the video and then work on the challenge. In some situations, we might want to use maybe something like we might want to use again time. So instead of just working again, I think actually you might want to use time as an index. So an index would be that column that would be on the far left. So if we have this data frame, this is our data frame that we had earlier. The index column is, this column that we have over here. By default, this helps to just uniquely identify the records. So again, we have this new data set that we have. It contains patients information, and to work with, maybe we wanted to convert to have this admission date as the date that there's the column that appears as an index. Then we can perform, first of all, we can perform that conversion, date time format conversion, using the toDateTime function. And then we set the index as shown, admission date. We use the setIndex function, and which we apply to the original data frame, and we specify the column that we want to set an index. And in place just replaces the old, it actually applies the change to the old data frame, which is the DF data frame. But generally, this operation for setting time as an index just allows us to be able to perform time-based operations such as sampling, resampling, slicing, as well as plotting. Pause the video and then work on the challenge. In some other situations where we are maybe creating data for, or we are preparing data for machine learning training, we might want to perform what is called encoding. Encoding just means replacing textual values that we have in categorical columns with numerical representations. So for instance, in a situation where we have such a column, and we have gender, diagnosis, treatment columns, which are categorical variables, we might want to convert those columns to have, numerical representations. So for instance, we might want to have gender to the male value in the gender column to have 0, then female 1, male 0, female 1. Then we can use one-hot encoding. There are different types of encoding that we can use. Actually, we can use one-hot, we can use label encoding, we can use the map function, which we are going to use to be able to perform those replacements. And when we use the mapping or the map function, we would need to first of all define a dictionary that contains key value pairs. And for each key value pair, you would have the original value, which is the male, and the value, that's the new value that will be contained. So for male, we want 0. For female, we want 1. If there are more unique values, then you would need to ensure that you figure out what those unique values are. And we are going to learn how to do that in a few, how to count distinct elements in a Pandas data frame, especially even in a Pandas data frame column. And once you have been able to define that dictionary, we use the map function to take that dictionary and apply the changes. So for male, we would replace our male values with 0, for female with 1. And we apply that to the gender column, and we replace the old values of gender with now the new values, new transformed values. And then we preview the updated data frame below. You can see gender, we have 0, 1, 0, 1, etc. Pause the video and then work on the challenge. In some situation, we might want to manipulate the index. So you remember this example where we set the index. We can decide to undo that step, like reset what we have as a data set initially. In such a situation, we can use the reset index function. So we would apply it to the original data frame, and that would give us the data frame, the final data frame. So if we had this data set that we see here, and we wanted maybe to set the patient ID, so this actually cell should come before what we have here. So if I run this cell, which would set the patient ID as the index, I can then reset by just using the reset index function and applying it to the DF data frame. Let me just do dset. Actually, I need to change df to dset. Yeah, so I can run this, and I should be able to see that I'm back at it again. So you'd have to change this df set because we are not. So what we have as a data frame that has this patient ID as the index, we've saved it as df set. So df set is our data frame that we need to reset. So that's why I changed here, and I changed it to df set initially. So you might note that particular change. So yeah, so that's something that you would be able to. It just helps you to just reverse that particular operation so that you can maybe use the data set for other for answering other data analysis questions. Pause the video and then work on the challenge. In some other situations, we might want to work with large data sets because maybe they might be helpful in answering research questions or helping other stakeholders. In maybe the case of a data engineer, if you're pulling a lot of data from just different data sources, then you might want to figure out a way of writing code efficiently, especially when you're doing data analysis. And if you work with terabytes of data, then it might not necessarily be. It might lead to you having a lot of computing resources being charged on where exactly you are processing the code. If you maybe use AWS or Google Cloud or Microsoft Azure, whatever platform, you realize for the amount of memory that you use to perform maybe data pre-processing techniques, then you'll be charged more. So one of the ways that we can be able to go about that particular operation of just being able to work with large amounts of data efficiently is to perform what is called chunking. So especially with Pandas. So if we have this data set that we see here and we wanted to work with it efficiently, we can load that data set in chunks. So if we had maybe 100,000, maybe if we had 100 terabytes, let me even start with 100 gigabytes. If we wanted to load that data efficiently, we could decide to load it in like 3 or 4 or 5 chunks. If it's 5 chunks, it means we'll be loading 20 gigabytes, and then performing individual pre-processing techniques on those gigabytes, individual chunks, and then later onwards aggregating our results. If we are doing data analysis, we could maybe do some sort of mathematical operation or statistical operation, such as maybe calculating the mean of each and every chunk, and then doing an aggregation of the results of each and every chunk. So yeah, so that's how we can be able to use. So we can be able to perform just what is called chunking. So where we use we set the chunk size parameter in read CSV function as the chunk size. Maybe we want 3 chunks for this particular data sets, and we use a for loop so that when we are loading this data set, we perform some operations on each chunk, and depending on the use case, you're able to just define your own chunks. All right, pause the video and then work on the challenge. In some other situations, we might want to count distinct elements in a Pandas data frame. So for example, like the one that I had given you before, where we are using the map function and we want to define the key values here. We may not be sure how many of the gender values that we have here. So instead, we might want to first of all count how many unique items are in this particular column, and then be able to define those values in the dictionary that we have. So in some situations, and we go back to counting distinct elements, we might want to count maybe distinct elements in a column, so like that particular case. So if we had this column, this particular case, we had this particular case, and we wanted to count distinct elements, maybe in the patient ID column, we would use the nUnique function. We apply it to the column of interest, so the patient ID in our case, in this example, and then we save the result in a variable, and then we print out the count of those, the count that we have. We have 75. We can also change maybe to gender, which we might want. So gender. That should give us 2, which basically it's just male, female. Yeah, so that's generally an approach that we could use. Pause the video and then work on the challenge. All right, moving on. In some other situations where we are performing data pre-processing and we would want to optimize our processes, we might want to perform maybe a data pre-processing technique such as filtering efficiently. So for example, in our case, we might want to filter for records where age is greater than 40. So this is our data set that we have here. If we wanted to get records which are greater than 40, we can first of all define what is, the condition for what we would want. So age is greater than 40. That's what we do here, and we pass that to the eval function to filter out for those patients. So eval will just give us the output, or which we would use. Well, actually, we would use eval to create a mask, a Boolean mask that we later use to filter for the data that we want. So in our case here, we just passed our condition, which we have our expression, to eval, which helps us to create the Boolean mask, which we pass now to the filter data frame. And this is a whole lot more efficient. And we can also do the same thing when it comes to calculating maybe metrics that we want, like age, the mean of age. This is a condition that we give to eval, and we are able to print out to have that as a result. Right, pause the video and then work on the challenge. In some situations, we might want to maybe select just columns that we want to work with only when it comes to data analysis. One of the methods that we could use is just using the lock method. So we would need to set two things inside it. So the first one would be double colon to set that we want to select all the records for the columns or for the data frame, comma, then we specify the column names that we want to work with as shown there. Sorry. Right, pause the video and then work on the challenge. Lastly, if we have been able to perform data pre-processing techniques, so assuming that we did processing, cleaned our data, what we can also do is to just, once we have cleaned our data, what we can do is to export it to a CSV file. So to do that, we just need the data frame name. So assuming that we had already done that, this patient's data, so we use the data frame name, then we apply the to_CSV function, and we set the name of the CSV function as well as the index to false, to just ensure that we don't have the index column included in the CSV or in the outputted CSV. So let me go to files on the far left. If I run this code cell, I should be able to see this new file being created. Actually, it will be created and populated here. So if I refresh here, you should see it here. All right, pause the video and then work on the challenge. Lastly, if we wanted to calculate maybe some summary statistics about the data all at once, we can use the describe function to be able to do that, or the describe method. To be able to do that, we just apply it to a data frame. So assuming this is our data frame, wanted to calculate maybe summary statistics of the data set. By the way, note that this data set we would need to set an index column. In our case here, we have this particular column as the index, which doesn't make sense. But for the purposes of just learning how to create summary statistics, we can be able to just showcase that by running this code. Just note that the columns that you have here, these columns do not represent the actual information. So what we have here actually is for age, and gender is for female. Should have seen that and updated that earlier. But the idea is just to understand what is happening. But when we apply the describe method, we actually do calculate some important metrics for only the numerical variables. So you'll see patient ID, gender, height, cholesterol level, and heart rate information that we see here. Right, pause the video and then work on the challenge. All right, so that's it with regards to this day's challenge, day 24. We hope that you were able to get some value from this particular resource, and are getting better and better at being able to perform data analysis work with the Pandas library. If you would want to be informed when we post the next challenges or future videos that help you in your learning journey as a data professional, be sure to subscribe. And if you'd want to tell us that we're doing a good job and to keep up the good work, be sure to give this video a thumbs up. All the best in your learning journey, and see you in the next challenge. That's on day 25. Bye-bye.